All right, let's just jump right in. We've all seen how amazing AI models have gotten, right? They're incredibly powerful. But there's this one huge problem. Most of them are kind of trapped, stuck inside their own digital box. They can't easily access our stuff, our personal data, our company databases, all the tools we actually use every day. So the big question is, how do we connect the two? How do we bridge that gap? I mean, that's really the core of the issue, isn't it? Think about it. Without a way to connect to the outside world, an AI is just, well, a really smart thing to chat with. To be genuinely useful, it has to be able to interact with our systems. But right now, the way we do that is a mess. It's like building a completely custom, unique adapter for every single plug you want to connect. It's a nightmare of tangled code. Surely there has to be a better way, right? And that better way, well, it might just be something called the Model Context Protocol. You'll hear it called MCP. Now, the absolute best way to think about this is like a universal USB port, but for AI. Imagine a single standard plug that lets any AI model connect to any data source or tool. You wouldn't need 1,000 different adapters anymore. Just one standard port. That's the dream. So this whole universal adapter idea isn't just some fantasy. It's a real, concrete, open standard called, again, the Model Context Protocol. It was pioneered by the AI company Anthropic, and their goal is huge. They want to create the blueprint, the common language that lets AI talk to the rest of our digital world. Okay, so here's the key takeaway. What MCP does is it sets up a standard client-server architecture. That might sound a little technical, but what it really means is that developers don't have to start from scratch every single time. Instead of building a custom connector for every new database or API, they can just build one server that speaks the MCP language for that service. And once they do that, boom, any AI that also speaks MCP can now connect to it. It's a build once, connect many kind of deal. No more of that endless, fragile custom code. All right, so to really get how this all fits together, we need to look at the three main players in this whole MCP ecosystem. It's actually a pretty simple but really powerful setup. It neatly separates all the different jobs that need to happen. So let's meet the cast. First up, you've got the host. This is the app you're actually interacting with, right? Like a chatbot you're typing into. Now, living inside that host is the client. The client's whole job is to be the translator, to speak that special MCP language. And then finally, you have the server. This is a totally separate service that provides a specific skill, like, say, fetching data from a database or searching the web. And this separation is absolutely crucial. The host and client are the brains, doing the thinking, and the server is the hands, doing the actual work. Okay, let's walk through a super simple request. Imagine you ask your AI assistant, hey, how many new customers did we get today? The host, the app you're talking to, figures out, okay, this person needs data. So the client inside of it sends a perfectly formatted, standardized request over to the analytics server. The server does its job, it queries the database, grabs the number, and sends it right back. Then the client passes that number back to the host, which turns it into a nice, friendly sentence for you. See? Simple, clean, and super efficient. Okay, so we've got the big picture. Now, let's zoom in a bit. It's time to pop the hood and look inside the MCP server itself, because this right here is where the real magic happens. This is the part that actually connects to real-world data and tools. So what are the core components that make this whole thing tick? So if you look inside, an MCP server is really built from 5 key parts. You've got a communication layer, which is how it talks to the client. You've got request handlers, which do the actual work. Context stores, which are for remembering things, session orchestrators, which manage those multi-step jobs, and finally, a caching layer to make everything speedy. These 5 pieces are basically the engine of the server. Let's break down what each one does. Okay, let's kick things off with one of the most important parts, the request handlers. This is the component that lets a server actually do stuff. You can think of these handlers as the server's toolbox or its list of skills. Every single thing the server can do, whether it's grabbing some data or taking an action, is powered by its own special handler. Now, what's really clever here is that MCP doesn't just lump all these skills together. It actually breaks them down into 3 distinct types. First, you have resources. These are for read-only things, like just fetching a document. Second, you have tools. These are for taking action, for doing things that have a side effect, like sending an email or saving a file. And third, you have prompts. These are basically reusable templates that help guide the AI and tell it how to behave. 3 clear categories for 3 different jobs. Let's make this super concrete with a simple example. Let's say we have a bookmark manager server. The AI client decides, hey, I need to save this link. So it calls the add_bookmark tool on the server. The server's handler for that tool gets the bookmark's title and URL. It then saves that info to a simple bookmarks.json file. That file is acting as its basic memory, its context store. And finally, it sends back a quick message like bookmarks saved. And there you have it. A tool just translated the AI's thought into a real action. Okay, but a server that just does one thing and then immediately forgets about it isn't all that useful, is it? It needs a memory. So now let's look at how MCP gives servers that memory, which allows them to handle context, manage complicated conversations, and just, well, work a lot more efficiently. The server's memory really comes from 3 different parts working in concert. You've got context stores, which are kind of like its long-term memory. Then you have session orchestration for managing what's happening right now. And finally, you have caching, which is like its super fast short-term recall for a quick performance boost. So, the context store. You can think of this as the server's permanent brain. It's where all the important data that needs to stick around lives. You know, in our little bookmark example, it was just a simple text file. But in a real-world system, this could be a huge database, a fancy vector store for searching, or even a connection to something massive like Salesforce. This is the component that lets the server remember things long after your current conversation is over. But what about those really complex tasks, the ones that take multiple steps? Imagine asking an AI to book a flight for you. It's not just one action. It has to search for flights, you have to pick one, then it needs your passenger details, payment info, it's a whole process. Well, that's what the session orchestrator is for. It's the project manager that keeps track of that entire workflow, linking all those separate requests together into one single coherent task. And last but not least, we have caching. This one's pretty simple but super important. Look, if you ask for the weather in New York, the server doesn't need to go ask the weather service every single second. It can just grab the info once and then store it for a few minutes. The next time you ask, it just gives you that stored answer instantly. The result? The server is way faster, more responsive, and, this is a big one, cheaper to run. Okay, I know that was a little deep in the technical details, so let's pull way back up to the big picture view. We've seen how the server works with all its components, but the real question is, why does any of this matter? What's the real-world impact of doing things this way? Well, it really comes down to 3 massive benefits. First up, maintainability. Because the AI's brain is separate from the tools, your apps become so much easier to fix and upgrade. Second, and this one is huge, composability. You can build a whole collection of specialized servers, one for your email, one for your calendar, another for your database. Then you can just mix and match them like Lego bricks to build these incredibly powerful and complex AI systems. And finally, control. This whole standardized setup gives you a much clearer and more accountable way to see and manage exactly what your AI is doing. There's a quote from the original article that just nails it. It says MCP captures a much-needed mental model for how we should build these apps. And that's exactly it. MCP isn't just another piece of tech, it's a philosophy. It's a clean, logical way to think about building AI applications that are strong, that can grow, and that you can actually manage in what's becoming a very, very complex world. And that really leaves us with a big, exciting question. Think about how OpenAPI became the universal standard for web APIs, or how Docker files became the standard for shipping applications. Could MCP be that for AI? Could this become the fundamental, agreed-upon way that all AIs interact with the rest of the world? It's a really powerful idea, and if it catches on, it could define how we build with AI for years to come.